Tyler, do you have to sit?
That's fine. Just leave it there, it's fine. Okay, so as I look at these, we are looking at different types of properties. Now, this is kind of common sense, like I said, we're just putting words with them. So, first property we're looking at is the commutative property. So, the way I remember commutative property is I think of commuting. So, draw a little car. Now, my car is going to suck, but that's okay, do the best you can. Okay? Draw a little car. Here's my car. It looks like crap, but that's okay. So, we are looking at a car. We are driving a car. We are thinking about the word commuting. If I commute somewhere, I go from, I commute to work. So I go from home to work, and then after school's over, I go from work to home. So I switch the direction that I commute. In the morning, I go from home to work, and then on my way back, I go from work to home. So, commutative property is the order of the values does not matter. I can switch the order of the values and it doesn't matter. Now, commutative property only works for addition and multiplication. Now, if I think about this, it's kind of common sense. If I have A plus B, okay, now don't freak out because I'm using letters. Letters in algebra are called what? Variables, and variables are just used to represent a what? Number. So instead of putting specific numbers, I'm using A and B to represent any number. So if I add two numbers together, the order that I add them does not matter. So A plus B is the same as B plus A. Now if I use actual numbers, it makes a little more sense. But if I take 5 plus 2, that is the same as taking 2 plus 5. So 5 plus 2 is 7, and 2 plus 5 is 7. So the order that I add numbers together does not matter. Like I said, it's kind of common sense. We're just putting words with this. We can also do it with multiplication. The way I multiply two things together, and we can represent multiplication with parentheses, the order I multiply two things doesn't matter. So A times B is the same as B times A. Remember, you can represent multiplication with parentheses or with the dot. You're probably going to see parentheses more in this class than the dot, but just so you see, the order I multiply two things doesn't matter. 2 times 3 is what? 6, and that is the same as 3 times 2. So whether I take 2 times 3 or 3 times 2, they are both equal to 6. Does commutative property work with subtraction? Let's think about this. What is 5 minus 2?
2 minus 5.
What is 5 minus 2?
5 minus 2.
What is 5 minus 2?
3.
3, thank you. 5 minus 2 is 3. If I switch the order, what is 2 minus 5? Negative 3. So you cannot switch the order of subtraction because you get two different answers. That kind of makes sense? 5 minus 2 is not the same as 2 minus 5. So commutative only works for addition and multiplication. Associative property. If I look at associative property, what school-appropriate word do I notice in associative? Or close to? Associate. If I think about associate, I'm thinking about associating with people. Okay? Associating with people are the people you hang out with. So the way I think about associating, or the group you hang out with, how do I group things together in algebra? What do I use to group things together? You guys know this. Parentheses. So associative property, we are going to use parentheses. Be careful. Just because you see parentheses does not mean it is associative. You have to have another specific thing, and I'll explain that in a second. So don't assume because you see parentheses that it's associative property. Associative property is grouping of values does not matter. So the order that I group things together, or the things I group together, it doesn't matter which things I group together. It works for addition and multiplication. So if I group, let's say I group A and B together first. So let's say I have A and B in parentheses plus C. That is the same as taking B and C and grouping them together. So So the key thing with associative property is you are grouping different things together. The left side I'm grouping A and B together. The right side I'm grouping B and C together. So just because you see parentheses, don't assume it's associative. You have to be grouping different things together. It also works for multiplication. If I look at multiplication, if I group A times B and then multiply that by C, that is the same as taking A and multiplying it by B times C. So you have to group different things together. On the left side, I'm grouping A times B together. On the right side, I'm grouping B times C together. They have to be different things that I group together on the left and right side. Does that make sense? Yes? If it doesn't, let me know. That's the point of this. Okay, good. Like I said, some of this is common sense. We're just putting words with it. Identity. Let's think about identity. If I think about the word identity, if I'm going too fast, let me know. You got it? Okay. If I think about the word identity, Marian health class, what kind of do you think of when I think of identity? Do what? The dentist. No, nice try though. Identity. If I ask about your identity, what will you give me?
My driver's license.
Yeah, stuff about yourself. You're telling me stuff about yourself. Okay? Identity is we are staying the same. You stay the same person. So if I ask for your identity doesn't change. You stay the same person through your life. So your identity is we are trying to stay the same. Identity, yourself, you stay the same.
Not if you change your name.
Right, but you're still the same person.
That's true.
Okay. So this only works for addition or multiplication. Don't overthink this. If I am adding something to A is just a number, what do I add to a number to keep it the same? 0. Like I said, some of this is common sense. If I want to keep a number the same with addition, the identity property says if I add 0 to anything, I keep the number the same. A plus 0 is A. If I look at a specific example, 2 plus 0 is 2. Anything added to a number, anything added to 0 is the same thing. So identity with addition, I keep it the same by adding 0. Now multiplication. I want to keep a number the same. What do I multiply a number by? A represents a number by to keep it the same.
0.
You said it.
Oh,
1. Because multiplying it by 0 makes it 0. I want to keep the number the same, so I multiply it by 1. So the identity property of multiplication is I take any number and multiply it by 1. 5 times 1 keeps it 5. I want to keep the number the same. Any questions on that? Inverse property. Inverse. What what does inverse mean in math and algebra?
Inside.
No. If I want the inverse of something.
Opposite.
Opposite. So we are going to use the opposite to cancel something out. This one's a little tricky, but we'll get through it. I want to use the opposite to cancel something else. Inverse means opposite. And then you have an inverse property of addition or multiplication. So think about I want to use the opposite to cancel something out. So let's think about addition. What do I add? A is just a number. What do I add to A to cancel it out? What is the opposite of A? Negative A. So I add the inverse, I add the opposite to cancel it out. What is A plus a negative A? No, 0. Now it's hard with variables. Let's think about an actual example. What if I have 4 plus a negative 4? 0. So inverse means I add the opposite, which gives me 0.
Wouldn't it be, wait, never mind.
Any questions?
Wouldn't it be a negative? The answer would be negative.
No, because 4 plus a negative 4. When you add a positive and negative of the same number is 0.
And I thought positive and negative made positive.
No?
Positive and negative make positive. Or
No.
positive and negative make negative.
Right, but if we're multiplying, but we're adding.
One and negative and negative. Oh.
Yes.
Okay.
Yes.
That's
Yep.
my bad.
Okay, you're good. Now, let's look at Multiplication. Multiplication is tricky, so ask me if this doesn't make sense. Let's say I have a whole number A. What is the inverse of A? We're not adding, sorry. We're not adding, we're multiplying. Put a dot. What is the inverse of A? If I think multiplication, what is the opposite of multiplication? Division. So if I multiply, what is the opposite of A? No? What if I put it over 1? Because I can write any number over 1 like we talked about yesterday. Now what's the opposite of A over 1? 1 over A. So if you have a whole number, it's one, you think about it over 1 and then you flip it. It's called the reciprocal, fancy word, don't worry too much about that. But the opposite when I do multiplication is you flip the fraction. Now what is A over 1 times 1 over A?
A over 1?
Nope. Think about cross-reducing. Nope. It's 1. Now, you're just saying random letters now. Now, let's look at an actual number. What if I have 4/5 times 5 over 4? Those are opposite. Those are inverses. So this is the inverse multiplication property. What happens to the 4s and what happens to the 5?
4s and 5s cancel out.
They cancel out. That just gives me 1. So it's easier to think about with actual numbers. But we are canceling out using the inverse. That's probably the trickiest one, inverse multiplication. Any questions on that? The next two are easy, and then I'm going to give you some time for homework. Zero product property. Don't overthink this. Zero product property. Zero means I'm probably going to have a 0 in there. Product means what?
Sum.
Product means what? Multiplying. Guys, keep your head up. We're not taking many notes. Product means multiplication. So we are multiplying by 0. The 0 product property means I multiply by 0. Multiplying by 0 is always going to be equal to 0. The notes are on the front, Michael. So anything times 0 is 0. Okay? Yes, like I said, some of this is common sense. We're just putting words with it. So anything times 0 is 0. 0 product property. 2 times 0 is 0. You know that. We're just putting words with it. Okay, distributive property. You've used this before. Most of you are probably pretty good at this. What if I have some, let's do an example first, and then you can kind of describe it to me. If I give you like this, and I say use the distributive property, 2 times the quantity of x plus 7, how would I use the distributive property to distribute? How would I use the distributive property on this expression?
It'd be 2x plus 14.
Okay, so 2x plus 14. Now, let's actually describe. You kind of know what to do, but what did I actually use? Yes, Xavier. Multiplication. So distributive property, I am multiplying. So multiply a value to an expression inside parentheses. So I take the number on the outside, which was the 2, and I distribute or multiply it by every term on the inside. So 2 times x plus 7 is 2x plus 14. Or if I look at another example, negative 6 times x minus 3. I have a number times something in parentheses, so I distribute. So what will negative 6 times x minus 3 be?
Negative 6x.
Okay. And then negative 6 times negative 3?
When we make it a positive, it'll be 18.
Positive 18. Okay. So you know this. You probably know how to use the distributive property, but just remember, we are multiplying what's on the outside by everything on the inside. Okay. Any questions on those? We're going to give you homework. We have a few other notes on the back, but I'm going to leave some more for homework. Okay, keep those out. We have a couple.